In this unit we discuss views, which are a way to alias tables or select statements. So we create sort of a virtual table. Let's take a look at how this works. Let's say I have a simple table. In this case I've got a list of perhaps some actors and the number of episodes of a particular series that each actor has been in. So normally I would just do a select star from actors and you would see the result that you see here. However, I could also create a more complex select statement, which we've learned about already. In this case, I'm going to select the first name and the last name in such a way that it selects one column with a column name of name, and it concatenates the names together, which is how somebody, might want to look for a name. And that makes sense. But what happens if we create a view? So basically, a view is where we can create a virtual table, a table that isn't real, but underneath that table is a real table. So when somebody does a query, in this case when they query this table called actor name that you see me creating in that statement, it's really querying that select statement that you see there, which is actually querying the actor table that underlies it. So the mechanics of how this works is you create that view. So Oracle creates a virtual sort of a virtual table. Now that table doesn't really have any data in it. There's no, with the exception of materialized views, which we'll talk about last, there's no actual data being populated in this second table somewhere. When you do a query on that view is dynamically getting the data from the real table that underlies it. And there's lots of interesting reasons to do this, which we'll discuss in a few minutes. But in any event, this is what a view would look like. So when you do a query against that view, so if you do, for example here, now I'm going to do a select star from actor names, which is actually querying the view, and that gives me my results. So my results are sort of proxied through this view. So it lets you do some interesting things. It lets you change column names and create something that looks like a different schema. But there's all kinds of reasons to do a view. They're pretty useful. Let's take a look at an example of how to create one. So we use the create keyword. The first one I'll talk about is or replace. You would use the or replace if you wanted to make sure that if the view already exists that it gets replaced. You can also do replace view. You don't have to do create view. But create or replace is nice because if the view is already there, it'll replace it. If it's not there, it'll create it. So it kind of covers both scenarios. A lot of database engines don't have that syntax. So all you can do is create, or you can do a replace. And you have to, a lot of times you'll have to do a drop first. So you do a drop view first, and then you do your create. But with Oracle, it's nice. We can just do create or replace. And then we have the force or no force option, which when we're creating our view, let's say you have a view you're creating, but the table is offline. Or maybe you've got columns that haven't been created yet. The force option will make sure that Oracle creates the view even if the underlying schema does not exist. The default behavior is no force, which means when you go to create your view, if the schema does not exist or it doesn't match what you're selecting in the select statement for the view, it's going to give you an error message and it won't create the view. But if we use the force, it'll force it to create the view anyway. So after we do create or replace, and then with the force option or not with that, and then the view keyword, we give our view a name, which can be pretty much anything. It's just like naming a table. So typically, syntactically, usually we name a view with the same structure that we would name a table. Some people like to prefix it with view so people know that it's a view. That way they don't think they're querying a real table. There are certainly reasons that you might want to know whether or not you're querying a real table or a view. For example, DML may not work in a view, but always works in a table. Next we have so there's our select statement. So after we declare our view name, we have our actual select statement. The select statement can be any valid select statement, and it can include a where clause. Can aggregates like group by, all that stuff can be in there. Everything we've talked about so far this semester can be in a view. And then next we have the with check option. So with the with check option, Oracle's going to make sure that if you do have a where clause in your select statement, that you can't do an insert or an update that's going to affect being able to view that with the where clause. So let's say, for example, you have a view that only shows records that begin with the letter A, and somebody goes to insert a new record that begins with the letter B. Now, if you did not have the with check option on, they would be allowed to do the insert statement, but they would never see that data from the view. So from the user's perspective, it looks like they've just inserted their data into a black hole. They'll never be able to see that data. So to work around that, you can use the with check option, which will make sure that when somebody does an insert, they can't see, or they can't successfully do the insert if they won't be able to see that data in the view. So it's sort of like a constraint. It's sort of a dynamic constraint. It makes sure that the constraint, in other words, is as long as it's going to work with the where clause, then it'll allow the insert. And of course, if somebody's doing DML on a view, if somebody's doing an insert, an update, or a delete with a view, all of the constraints in the underlying table are still in force. So you can't get around the constraints that are created in the underlying table. So for example, if you don't insert a primary key, or if you violate a foreign key constraint, those inserts would still fail on updates and so forth. And then finally we have the with read-only option. So as I said, with a view, they do fully support DML. Not always, though. There are certain views where DML won't work. We'll talk about when that happens. But with the read-only option, you basically are telling Oracle not to allow any insert, update, or delete through a view. You're saying through this particular view, you don't want to allow anyone to do anything except do a select statement against the view. So let's take a look at an example of a simple view. So a simple view typically is just one table. So it's typically some sort of select statements against one table. Maybe you change the column names and so forth. So let's take a look at an example. So I'm going to create a view on this actors table as select last name, but I'm going to alias the column name as L name, and then first, but I'm going to alias that as F name from the actor table. So then my virtual table looks something like this. It just has the L name and the F name. Of course, the L name would probably be spelled correctly, but other than that, this is basically what it would look like. And then if I do a select statement from this new actors table, which is my view, it's going to select from that view, and it's going to have the same structure as my view. So why would somebody do this? One of the big reasons that I do this, I use views heavily in most of our application development, and the reason is if I create a table and I write code that works directly with that table, then anytime there's a schema change in the table, my code has to get updated, and that's okay. But what a view allows me to do is I can have my underlying table, but then I can put a view on top of it, and then my applications all interact only with views. As far as DML goes, when it's a simple view, where all I'm doing is maybe changing a column name or something along those lines, then it works just as if it's a regular table. But the really interesting thing is I can make a change to the underlying table, and it won't affect the view. So if, for example, I can change a column name in the underlying table. Maybe somebody comes along and says, well, we don't want to call it a last name anymore, or last, we want to call it last name. We don't want to call it first, we want to call it first name. Well, all I have to do is change my view. I don't have to go and change anything in my code that uses the database, my application code. So if you're looking at application development with the MVC model, using a view definitely makes a lot of sense. It's going to help your application work through changes that are made in the back-end database without having to update that code. And there's also some other interesting. I've used views in applications where maybe I have an application, a class, or some library that uses a database, and it's coded to use the database a certain way. It's looking for certain tables with certain column names, and I know what that schema is. But if I don't have access to the source to modify that code to change how it queries the database, instead of modifying the application code, I can go in the database and create views that alias all my tables to make it look like what that view is looking for. So I can kind of trick applications into thinking they're using a database with a different schema. They don't have to know that the underlying schema is something completely different. So views can be very interesting, and they can be also they're very useful for integration and anything where you want to separate the underlying schema from front-end application code. And there are lots of other uses for views. So one of the other things you might see views used, and we're going to talk about complex views, is if you have extremely complex queries that you don't want to have to run over and over again. You don't want to have to code it into your application. You want that to be where it belongs in the database. So usually complex database code should be in the database, and a view allows us to do that. We can create a view where an application doesn't need to know the underlying minutiae of how to create some complicated data view. All it does is query the view. The view is doing all that work for them, and then a database administrator can make changes to that view over time. So let's do one more thing with this simple view. We're going to do an insert statement. So if I do an insert to this basic view, so I'm going to insert into actors just a simple name, it's going to write that name into the underlying table, and of course you'll be able to see it from the outer view. Let's look at one more example. So in this example, with a simple view, I've added a where clause. So now we're only going to select where the count is greater than 70. So if there are more than 70, if the actor is in more than 70 episodes of a particular series. So when I select on this view, I'm going to get a shorter list. I'm only going to see three actors, the three that are over 70. If I try to do an insert statement, so let's say I try to insert this particular actor, this is going to work. So it's going to insert the actor. The problem is that actor doesn't have a count. So if my view, as you can see, is still not going to show this new actor that I added, this Eddie Paskey actor. I won't see it there because it doesn't have a count, so it's not greater than 70. So it's not going to be displayed. So I may not want that to happen. I may not want somebody to be able to do an insert like that. So if we add the with check option, now when somebody does an insert, so you can see my insert statement at the top. I'm trying to insert into actors an actor named George Takei, and when it tries to do that insert, it's going to fail because it's going to say, hey, this violates the constraint with the check option. It's not. It doesn't have a count that's over 70. And of course, in this case, an insert statement would never have a count over 70 because it's not possible to do an insert on a column that doesn't exist. So my view does not have a column for count, so I can't insert a count. And if you tried to, it would fail. Some students think, well, gee, if the count's in the underlying table, I should still be able to use that column, but you won't be able to use it. So let's look at an example of a complex query. So let's say in this example I've got three tables. I've got actor, which we've already been looking at, perhaps a table of cast and episode, and the relationship between those tables is such that an actor can be a member of a cast, and a cast can have an episode, and an episode always has a cast. So I've got these foreign key relationships here. And let's say I wanted to create a table. In this example, let's assume that my actor table doesn't have a count field, and I've got lots of different episodes and lots of different series that actors might be a member of. So in this example, I could create a very complex query. So if you ignore the create view part of this query and just look at the select statement, I'm selecting the actor ID, the last name, and the first name of the actor, and I'm getting the count for the number of episodes that actor was in. And then I'm selecting that from actors. Then I'm joining the episode table. I'm checking to make sure that in the where clause, I'm making sure that the episodes that it selects are only ones that are from the series where the title is like Star Trek. So it has to start with, there could be Star Trek The Next Generation, Star Trek The Original Series, Star Trek something else, whatever. But it has to be one of the Star Trek series. And then it would show their total number of series that they were in. So this is a very complex query, and we can create a view with this query. And this has a little bit of almost everything that we've discussed so far this semester, as far as with the exception of a function, other than perhaps the count function that we have there. So again, this is very complex, and if I pre-can this view, so basically the result of this view is going to be a table that looks very much like what we've been working with so far. So if I didn't have that count field, and it was just a list of actors, and it had no context to casts and episodes and series and things like that, I could virtually create that table to work with it. So the problem with this, though, so the issue with a complex view like this is DML will not work. For the most part, DML will not work because a lot of this. So, for example, you wouldn't be able to update the count because the count's derived from other tables. So a lot of people make the mistake that DML will not work when you select from more than one table, and that's not necessarily true. If you have a simple join, so if you're using the join keyword or you're using the traditional join method, in many cases those will actually work doing DML on those records. Not always, but in many cases it will work. But one sure way to make it so that your DML will not work is if you've got aggregate clauses or if you have columns that are derived from other columns. So that's a case where you might have DML where DML would not work. Next we have an inline view. So an inline view is where we create the view right in our select statement. So take, for example, this table that I have here. So maybe in this table I've got the actor name, the season numbers, and how many episodes per season that actor was in. And if I wanted to get a count on the overall number of episodes each actor was in, I would have to do something like this. I'd have to select season 1 plus season 2 plus season 3 plus season 4, and then I could alias that as count. So, for example, this is what my table would look like. I've got my counts, so it looks just like what we've been working with before. I could create a view with this, but here's the problem. Let's say I want to do an analysis where I want to pick the top 3 actors. So the 3 actors that were in the most episodes. So the problem with doing that, so one thing you could do is where row num is less than or equal to 3, and that would give you the top 3 results. However, we want to make sure we get the top 3 actors, so the 3 actors that were in the most episodes. I can add an order by count, but this isn't going to work because the problem is that order by is going to happen before the row num, so you may not actually get the top 3. So what we want to do is we want to select first with the order by and then check the row num. Because the row num is going to be based on their position as they were inserted into the tables, not based on the ordering. So the ordering happens after it gets the row numbers. So all it's going to do is take the first 3 people that were inserted. Well, if Doohan and Nichols were inserted first, they're going to show up as the top actors because they were inserted before Kelly, who maybe has more episodes. So again, we want to make sure when we do a top N analysis, we have to select first with the order by. That'll be a virtual table. Then we can do our row nums, because at that point the row numbers will be recreated because our virtual table is going to have its own row numbers. It's not going to inherit that from the underlying table structure. So this is how we would do that. We're going to do a select statement as normal. So I do a select last first count. Then you can see I have a select statement that looks an awful lot like like a select statement from a view, but I also have the order by. So it's going to the order it's going to execute the statements. First, it's going to do that select last first season 1, season 2, season 3, season 4 as count from actor, and it's going to order it. So first, it's going to get that list of actors, order it by the count, by the overall count. So that's going to happen first. Then it's going to select the last first and count, but only where the row num is less than or equal to 3. So I'll get the top 3. So this will do exactly what I'm looking for. So this would be an inline view because we're basically doing the view where normally we would put in a table name. Instead of a table name, we're creating a table virtually as a view. The last example is a materialized view. So we'll go back to the table I used for the complex view. So this complex view has a lot of stuff going on. We've got aggregates, we've got selects that are derived from other columns, all kinds of things happening here, and it's going to take a lot of processing to display this query each time. So we may not want to have, every time somebody wants to get a list of actors with their counts, maybe we don't want it to actually go into the database and do all this work each time. So we could cache these results so that it's much faster when somebody calls this view. If I don't cache these results, every time somebody does a select from actors, select star from actors, it's going to run all of this code that you see here, and that you might use a lot of memory. That it might, if you've got millions of people in the database, it could take a while for it to run this logic. It could be 10 minutes to run this query if it's not well optimized, or if there's a lot of data with a lot of joins and all kinds of interesting things happening. So instead, we can create a materialized view. So a materialized view is going to combine, it's going to create that virtual table, but it's actually going to store that data in memory somewhere. So it's actually going to create that data. So this is a little different than the rest of the views. All the simple, complex, and inline is all virtually happening in memory. It's happening each time somebody does a query. With a materialized view, and to make this materialized, by the way, instead of just doing create view, we do create materialized view. So you would have the materialized keyword in there between create and view, and it would create that table. And you can think of it as sort of a freeze frame. It's sort of frozen in time, that data. So in other words, if somebody does an insert to the actor table later on, it's not going to affect this table. So this table is sort of frozen in time. So if you wanted to rebuild this virtual table, you'd have to create that materialized view, or create or replace the materialized view to recreate it. So this could be something that you do once a day, or it could be something that that happens periodically. The other use for this is if you're doing some kind of data analytics where you want to freeze everything in time without doing a lock. So if you recall from several weeks ago, we talked about doing a lock. When you do a select, you can lock a table while you're doing some analysis. Instead of locking a table, let's say you're going to be doing some analysis that's going to take an hour for it to run. You don't want to lock that table for that entire hour. So instead of doing a lock on the table, you could do a materialized view on that table, which kind of freezes what you're looking for in in time. Do all of your analysis, and then you just delete your materialized view, and you don't have to worry about tying up database resources. So again, we had 4 options. We had a simple, complex, inline, and materialized view. And this was a relatively short chapter, but this is the last chapter for the semester.